In this video, we're going to focus on finding the molar mass of a compound. So let's start with the basics. What is the molar mass of elemental nitrogen? Not nitrogen as a diatomic molecule, but as an atom. Well, if you go to the periodic table, you'll see two numbers. The atomic number of 7 and the average atomic mass of 14.01. The molar mass is equivalent to this number. It's 14.01 grams per mole. The molar mass is basically, it connects mass with moles. So that's the molar mass of N. It's 14.01 grams per mole. So what that means is that 1 mole of nitrogen has a mass of 14.01 grams. So let's say if we wanted to find the molar mass of atomic fluorine. Fluorine has an atomic number of 9, but a mass number of 19. So this is the molar mass of fluorine. It's 19 grams per mole. So every mole of fluorine atoms has a mass of 19 grams. Now, what about some other molecules? For example, let's find the molar mass of O3. This is ozone. It's found in the upper atmosphere. And S8, elemental sulfur. Find the molar mass of these molecules. O3 contains 3 oxygen atoms. Now, if you go to the periodic table and you look for the average atomic mass of oxygen, you're going to see two numbers, 8 and 16. The larger of these two is always the molar mass. So the atomic mass of oxygen is 16. If you multiply by 3, that's 48. So the molar mass of ozone, O3, it's 48 grams per mole. Now, what about the molar mass of sulfur, S8? So what we have is 8 sulfur atoms, and the average atomic mass of each sulfur atom is 32.07. So what we need to do is multiply 32.07 by 8. And so this will give us the molar mass of sulfur. It's 256.56 grams per mole. So as you can see, it's very easy to calculate the molar mass of something. But let's try some harder examples. Go ahead and find the molar mass of carbon dioxide. Perhaps you've seen it as dry ice. And also silicon tetrafluoride. So feel free to pause the video and try these examples. So CO2 contains 1 carbon atom and 2 oxygen atoms. Now the atomic mass of carbon is 12.01 and oxygen is 16. So 2 times 16, and that's 32. And 32 plus 12 is 44. So the molar mass of carbon dioxide is 44.01 grams per mole. Now let's do the same thing for silicon tetrafluoride. So we have a single silicon atom and 4 fluorine atoms. The atomic mass of silicon is 28.09. The average atomic mass of fluorine is 19. 19 times 4 is 76. Now let's add that to 28.09. So therefore, the molar mass of silicon tetrafluoride is 104.09 grams per mole. So this is the answer. Now let's work on another example that has more elements. C6H12O6. This is glucose. Perhaps you've seen it in bio. It's basically a molecule that provides energy for cells. So go ahead and calculate the molar mass of glucose. So we have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. What I like to do is I like to separate the elements. So as you can see, there's a process in which I like to calculate the molar mass. Each carbon atom has an atomic mass of 12.01. And each hydrogen atom, if you look at the periodic table, it's 1.008. And we've seen oxygen multiple times, so we know the atomic mass is 16. Now, 6 times 12 is 72. And 6 times 0.01 is 0.06. 12 times 1 is 12. 12 times 8 is 96, so this is going to be 0.096. And 6 times 16 is also 96. So now all we need to do is simply add these numbers together. So the answer that I have is 180.156 grams per mole. So that's the molar mass of glucose, a typical monosaccharide. Sometimes you may need to find the molar mass of a substance for which you're not given the chemical formula. Like this one. What is the molar mass of calcium phosphate? Before we could find it, you gotta write the formula. So you need to know that calcium phosphate is an ionic compound. It's composed of a metal and some nonmetals. So we need to find the charges. Calcium has a positive 2 charge. It's in group 2 of the periodic table. And phosphate is just one of those polyatomic ions you need to know. So the formula is going to be Ca3PO42. You need to switch the charges with the subscripts and reverse them. So this substance has 3 calcium atoms, 2 phosphorus atoms, and 8 oxygen atoms. 2 times 4 is 8. Now, each calcium atom has an atomic mass of 40.08. Phosphorus is 30.97. And oxygen has an atomic mass of 16. Now 3 times 40 is 120. 0.08 times 3 is 0.24. 2 times 30.97, that's going to be 61.94. And 8 times 16 is 128. So now we just need to add these 3 numbers. So I got 310.18 grams per mole. So that's the answer. That's the molar mass of calcium phosphate. So here's another example like the last problem. In this problem, you got to write the chemical formula first before you could find the molar mass. So what is the chemical formula of vanadium 5 hydrogen phosphate? So vanadium is a metal. Hydrogen phosphate is a polyatomic ion composed of nonmetals. So we have an ionic compound again. Now the Roman numeral tells you the charge on vanadium. So in this example, vanadium has a positive 5 charge. Hydrogen phosphate is HPO4. You have a hydrogen attached to a phosphate molecule. Phosphate is PO4 with a negative 3 charge. Hydrogen is H+. When you combine these two, you get hydrogen phosphate, which is HPO4, and then you add 1 and negative 3, and that will give you negative 2. So that's the chemical formula of the hydrogen phosphate polyatomic ion. Now let's use the same method to write the formula of this substance. So it's going to be V2HPO4 times 5. Whenever you have multiple polyatomic ions within a compound, you need to enclose it inside a parentheses. So now that we have the chemical formula of vanadium 5 hydrogen phosphate, we can now calculate the molar mass. So we have 2 vanadium atoms, and then we have 1 times 5, so 5 hydrogens, 1 times 5, 5 phosphorus atoms, and then 4 times 5, 20 oxygen atoms. So now let's look up vanadium in the periodic table. Vanadium has an atomic mass of 50.94. Hydrogen is 1.008. Phosphorus, 30.97. and oxygen 16. So first, let's multiply 2 by 50.94. So that's 101.88. And then 5 times 1.008, that's going to be 5.04. And then 5 times 30.97, that's 154.85. And 20 times 16 is 320. So now let's add up these four numbers. So I got 581.77 grams per mole. So that's the molar mass of vanadium 5 hydrogen phosphate.